Now let's look at this very beautiful function notation question here. It says that if f of x plus 1 over x plus 4 equals x squared plus 1 over x squared plus 16, find f of 19. Now, before you watch this video, I advise us to go back to my previous video on function notation. I explained the meaning of function notation and how to understand function notation. Now, what are we going to do here? Now, let us quickly go back to the introduction of function notation for a better understanding so as to follow up in this video. Now, when you see something like, if you are given a function notation like a function equation like f of x equals, let's say, x squared minus x, and then after that, what is going to be the value of f of 1? Very simple. Function notation means wherever you see x at the right hand side, you impute what? 1. Therefore, f of 1 will be, we have x here, we put 1 squared, minus we have x here, we put 1. So f of 1 will give us 1 squared minus 1 is what? 0. F of 1 will give us 0. Easy substitution. What if we now have a little bit twist? In a case like when they say f of x over 2 equals x over 2 squared, let's say plus minus, let's say x over 4 for an example. Now, this, and that's that you find f of negative 1 in this case. What do we do again? Easy substitution. Wherever we see x over 2 at the right hand side, we impute negative 1. But at the right hand side now, we have only x over 2 here. We don't have x over 2 here directly. So that means we have to extract x over 2 from this because we can only substitute negative 1 into x over 2 and nothing else. So we write this one as, we can write it as x over 2 squared minus 1 over 2 times x over 2. Yes, 1 over 2 times x over 2, because 1 times x will give us x, 2 times 2 will give us 4. So we haven't done anything wrong. So finally, we can now make use of our substitution. Now, f of 1 will now give us, wherever we see x over 2, we put 1. So 1 squared minus 1 over 2 times 1. So therefore, f of 1 will now give us 1 minus half. Will give us what? Half. As simple as that. So this same idea, we are going to use it here. So here now we have f of x plus 1 over x plus 4 equals x squared plus 1 over x squared plus 16. How are we going to do this? We just will find f of 19. F of 19. How are we going to do this? So this means that wherever we see x plus 1 over x plus 4 at the right hand side, we should input what? 19. But now there's a problem. At the right hand side, you don't have x plus 1 over x plus 4. Rather, we have x squared plus 1 over x squared plus 16. So what this means is that, just like I've done here, we have to extract x plus 1 over x plus 4 from here. Anywhere x appear, it must be in this form. Like at the right hand side, it must be this form, not like this. So we're going to manipulate and do a lot of simplification here. So, but before that, let's rewrite this as f of x plus 1 over x plus 4 equals to x squared plus 1 over x all squared plus 16. Now, I haven't done anything strange here because 1 is something as saying 1 squared, okay? So 1 squared over x squared. So they have square and square. Law of indices, we can bring them together as 1 over x all squared, okay? Then plus 16. Now, when we look at this expression on the board, it's actually looking very, very familiar. This x squared plus 1 over x squared is looking very familiar. Where have we seen it from? Yes, we have seen it from alpha beta expansion. That's from algebraic identity. What's that alpha beta expansion? Don't forget that when you have something like alpha squared plus beta squared. Now we can write alpha squared plus beta squared as alpha plus beta all squared minus 2 alpha beta. Alpha plus beta all squared minus 2 alpha beta. But in this case, instead of alpha, we have x, beta, we have 1 over x. So we can write x squared plus 1 over x squared using this identity as, that's, we're going to have alpha plus beta, that's x plus 1 over x all squared, right? Then minus 2 times x times 1 over x, then plus 16. Very, very good. We have to write this like this, okay? Now, the next thing is not to simplify. So from here, we'll now have f of x plus 1 over x plus 4. We will now have x plus 1 over x all squared minus x cancels x. X cancels x, right? So we're going to be having 2 plus 16. So negative 2 plus 16 gives us what? Yeah, we still have x plus 1 over x squared. Negative 2 plus 16 gives us what? Plus 14. Now, when we now look at this, we have now made a little bit progress because at the left hand side it says x plus 1 over x plus 4. Wherever we see it, we put 19. But then now we have x plus 1 over x. 4 is still missing here. All these xx, we will bring them together as x plus 1 over x. We still mean 4. Because 4 must be here before we can input that 19. What do? We make use of addition identity. That is, negative 4 plus 4 gives us 0. Nothing wrong. So we can say this is x plus 1 over x plus 4 minus 4 all squared plus 14. Do you see that wisdom? Because 4 minus 4 will give us 0. It's as if we have done nothing. So we haven't done anything wrong. Therefore, here now we can now write this as, let me use another bracket to distinguish it. X plus 1 over x plus 4 minus 4 all squared, then plus what? 14. Now, we now have this at the right hand side. We can now make use of our direct substitution. So it means that, therefore, f of 19 will now be, wherever we see x plus 1 over x plus 4, at the right hand side, we input 19. So that will now be 19 minus 4 all squared plus 14. So that will give us 19 minus 4 is going to give us 15. So 15 squared plus 14. So therefore, finally, f of 19 is going to give us 15 squared is 225. Then 225 plus 14 will give us 239. So we have 239 as our final answer. Very, very simple. So can you see that function notation just has to do with direct substitution? Is not hard. We understood this. If you have any question, let me see in the comment section. And please don't forget to subscribe. It's very, very important as a way of supporting my channel and also to learn more mathematical stuff like this. Till I come your way next time. Bye.